Today we are going to do brake test on 3-phase squirrel cage induction motor. 3-phase squirrel cage induction motor. What we are going to do? The aim is to determine the efficiency and performance characteristics of 3-phase induction motor by doing performance load test as or brake test. So here, if you observe, we need voltmeter MI type. MI means moving iron, 0 to 600 volts. So this is the voltmeter MI type 0 to 600 volts. Next, ammeter MI type 0 to 10 amps. Now I am taking an analog ammeter, that is moving iron type 0 to 10 amps. And next we are taking two wattmeters. One wattmeter is of 0 to 600 volts, 10 ampere, and the pointer should be at the middle. Okay, it has to go to the negative, it has to go to the positive. It should be like that. So another wattmeter what I have taken is of 0 to 600 volts, 10 amperes, but the arrow mark is at the starting. And not only that, one tachometer. This is the tachometer, and in this tachometer, how to use this tachometer? There is a red color button. We have to press this button, and we have while it is rotating, it will show the speed of the motor in revolutions per minute, rotations per minute, RPM. Okay, instead of using this, we can even use an RPM meter also. If it is a distalized, automatically it will be show you RPM meter. Otherwise, you have to use tachometer. Now, coming to the connections. See, here we need to see the circuit and we need to connect it. So here, if you observe carefully, this is the connections. So here, this is a 3-phase, so R, Y, B connections are there, and here input is given as 3-phase 440 volts 50 H supply, AC supply, and from here there is a TPST switch, triple pole single throw. So this is considered as TPST switch, and after TPST switch we are using 3 fuses. So this is the fuses. Okay, sir. These are the fuses. And from here there is a start to delta starter. I will be showing you. So this is the start to delta starter. Okay, so I will show you how to use. And after start to delta starter, the connections are made. So here we have to do connections from this point, and from this point. So this is R, this is Y, and this is B. So this is R, this is Y, this is B. And for your better understanding, I have connected red color wires, and Y for yellow and B for blue color. Okay, now the connections are started. So here, if you observe carefully, from here there is one wire should be connected to the ammeter, and another wire should be connected to the voltmeter. So we have to come from a starting. So from R, ammeter. So this is from here. I am connecting one wire to ammeter of 10 amps, and from R I am connecting voltmeter. From R I am connecting voltmeter positive. So I have completed this connection. Next, from ammeter, now I will complete this. After that, I will go to the next line. So from ammeter, I have to connect to the wattmeter. If you observe carefully, these are the main points. This is one point, this is second point, and this is third point, and this is fourth point. So this first point is said to be M. M is for mains, L is for load, C is for common, and V is for voltage. So M and C, it is not inside the wattmeter, it is outside the wattmeter. So we have to short circuit the M and C. So I am taking a wire. Okay. So from first of all, from ammeter negative to M. From ammeter negative to M. So here I am connecting from ammeter, from ammeter common to M. This is M. So at the same time, M, C should be short circuited. So So I am taking M, from M I am taking two wires, one is to the ammeter, another one is to common. So this is M, from M in this circuit from M to C short circuit, so C should be short circuited. Okay, next, so we have connected up to here. Next we have to go for the L, from L to, see here, from L, so ikkada L ante ikkada ekkada undi, ikkada undi, so from L to load. So from L to load means this is the point where we have to connect. Now I have completed this connections. Next, from V to Y. So already if you observe carefully, from Y it is going to wattmeter 1 voltage, and from Y2 it is going to wattmeter 2 voltage, and from Y it is going to the motor Y terminal, right? So three wires I need. So from V to Y. See, for the easy way of connecting, first what we have to do is, first we have to check from this point how many wires are going. So from R to ammeter one wire, for R to voltmeter one wire. So here we need to connect two red wires before itself. Next, from Y it is going to V for wattmeter 1, and from Y V2 wattmeter 2, and from Y again to the load Y, to the motor Y. So how many wires are there? 1, 2 and this is 3. So 3 wires, yellow wires should be connected over here before itself. And next, from B, if you observe carefully, one wire is connected to voltmeter negative and one wire is connected to the M of the wattmeter 2. So 2 wires we have to connect. So 2 wires we have to take like this. Then it will be easier for us to give the connections. So from V to Y. So we have to take one Y and we have to connect to the V. And here in this wattmeter, V means, see the rating of the wattmeter, 10 amperes, 600 volts. So V should be connected to 600 volts. So here if you observe carefully, there is a 600 volts terminal here. So this is considered as a voltage, 600 volts. So we have to connect this yellow wire to the wattmeter. And after that, we have connected. So we have completed up to this one. Next, from Y to motor Y. So we have to take yellow wire again, and from here you have to connect to the motor Y. Okay. Next, one more wire is there. That is from Y to voltmeter of Y to V of wattmeter. So again, take one more yellow wire and connect to second wattmeter 600 volts. So if you observe carefully, this is the 600 volts. So here I am connecting second wattmeter. So now if you observe, I have completed connections from Y to V, Y to V and Y to Y. And next I am going to the third B terminal. So from B to one wire should be connected to the voltmeter. So from B to one wire should be connected to the voltmeter. And another wire should be connected to the M of the second wattmeter. So I am taking blue wire, again one more wire, and I am connecting this one to M. And not only that, here as we have seen before, here also M and C should be short circuited. So I have to take another one more wire and both should be connected in M. And after connecting these two wires, after that we have to connect to the C should be connected to common. So from M, C, we have to connect this wire. Okay, now we have completed this side, and V also we have connected. and the only one thing is left is from L to motor B. So from L to motor B. So you have to take a blue wire from L to B phase. From L to B phase we have to connect. So the connections are over. So this is how the connections should be. After connecting, you have to keep this meters like this, such that we will get proper readings without any error. Because as these are analog meters, the needle, the pointer weight also will be calculated. So we have to put like this. This is the right way of using. And here we have to know the precautions first. What are the precautions here? First precaution, avoid loose connections. First precaution is avoid loose connections. And the second precaution is there should not be any load at the time of starting. If you observe carefully, this belt should be free. There should not be any load. It should be free. There should not be any load at the time of starting. That is the second main precaution. And the third precaution is pour water in the drum. Pour water in the drum. This is called as motor drum. So in this drum you have to pour water. It will work as a coolant when it is loaded. So after that, so these are the main precautions. First one, avoid loose connections. Second one, there should not be load at the time of starting. Third one is pour water in the drum. Okay, next procedure. So procedure, before starting, we have to check the nameplate details. So before starting the procedure, see the nameplate details. Okay, every motor will contain this nameplate details plate, and here they have written the information. So that one we can see. So here this is the nameplate details which was written and kept on the board, and if you observe carefully in this you can see amperes, AMPS. So what is amperes here? 7.4 amps. So while applying load, it should not go more than 7.4 amperes. And what is the rated speed? 1440 RPM, right? So it should not go more than 1500 RPM. So these are the main terms which you need to check while doing this experiment. This is the S1 and S2. So we have to take down the readings from S1 and S2 as these are not loaded. It will be indicating as 0 value. Okay. And this is how we have to check the speed while rotating. So we have to press this button and we have to put in the same axis in this motor, and while it is rotating, it will show the speed in RPM. So this arrangement is no need for this one, as it is having automatic sensor and it will be showing in the RPM mode. So we can use this tachometer or we can use this RPM. So here is the tabular column. If you observe carefully, this is voltage, and this voltage from voltmeter, and this amps from ammeter, and in the wattmeter we are using 2 wattmeters. So W1 and W2 values, and there I have shown you S1 and S2 weights, right? So S1 value, S2 value should be written here, and the speed should be taken in RPM, and that should be written over here. So these are the readings what we have to take primarily. Now about the procedure. Here if you observe carefully, first switch on DPST switch. So by telling the procedure, I will do the experiment. Okay, so switch on DPST switch. So this is a TPST, triple pole single throw. Actually this is 4 PST, but actually 3 poles will be there. So this is a switch on TPST switch, triple pole single throw. After switching on, switch on the automatic digital meters on, and after that switch on This is a star delta starter. After switching on TPSC switch, we have to switch on the star delta switch starter. You have to know how to use this. So there is a switch over here. We have to press this one for some time. Once you feel that the motor is running with a constant speed, then with no time you have to press, you have to move this one to the upwards with a high pressure, such that the motor runs with a rated speed. We should not do late. If you do late, the switch won't work. So see, now I am switching on the star delta starter. First I am switching on. Now the motor starts running, and now after feeling that the motor is running with a constant speed, with no time I have to switch on that to other cycle like this. So take out your hand carefully, then the motor starts rotating, and after that we have to take down the readings. So here, as we have to switch on the motor and we have to take down the readings. Switching on, take down the corresponding readings. Take down the voltage of 416 volts. So V should be taken 416 volts. Next current should be taken as it is of 10 amps, so double this, so 1.5 it is. So I have to take into 2 because these readings are for 5 amps, and after so 5 into 2 10, so 1.5 ante 3 amps actually. So 3 amps, and the wattmeter reading is minus 200 amps, 200 W1 wattmeter reading is 200, and next wattmeter 2 reading is that is minus 200, and this is plus 250 plus and 50. So this is the wattmeter readings, right? So after taking that, take S1 value, that is of 0 only because we have not applied the load, and S2 value also take 0. Okay, and the speed in RPM is 1498, and these readings are said to be no load readings. Load vehicle readings ni no load readings antaru. Ee readings anni no load. Now apply the load gradually. So we have to apply the load by seeing the ammeter. Ammeter chustu we have to apply the load. So now it is of 3 amperes. So I am going to 4 amperes. So 4 amperes, and again take down the corresponding readings. So see here, S1, S2 also changing. So like that you have to take down the all readings. Even the speed also will get decreased. Now again apply load to 4 amps to 5 amps. Take down the corresponding readings. Again apply to 5 amps. Take down the corresponding readings. Like that, do this cycle regularly, but it should not go more than 7.4 amps as the rated current is 7.4 amps. Okay, after that reduce the weights, and switch off TPSC switch by pressing this red button in star delta starter, and switch on the main switch also, main control also. We have taken wattmeter readings, but in the wattmeter readings there are many things to consider. Here the wattmeter reading is 600 volts and 10 amps. So there is a multiplying factor over here. So if you check carefully, there is a 600 volts and 10 amps. 10 amps means here we have connected B1, B2. So see, for 10 amps connection, join B1 and B2. So because of that I have joined B1 and B2. Okay, so we have connected 10 amps and 600 volts. So what is the multiplying factor here? 10 amps, 600 volts, that is 4. So whatever values you got in this wattmeter, you have to take into 4, whatever readings you got. In the same way, here also the same wattmeter, here also for 10 amps join B1, B2. So we have joined B1 and B2 with this, and we have connected to 600 volts, right? So 600 volts, 10 amps, we have to multiply with 4 for this wattmeter also. This is very important, which we need to Remember. Now coming to the calculations part. Here we have taken all the readings. First reading is the no load reading. After that we have applying the load. We have taken the readings up to 6 amperes. So in this 6 amperes, see carefully. So we have taken W1 into multiplying factor, W2 into multiplying factor, tarvata S1 value, S2 value we have taken by applying the loads, and after that speed in RPM we have taken by applying the loads, and after that we have to calculate the torque value. Torque value means, what is the formula for torque? Torque is equal to 9.81 into S into R. R is the radius of the drum. If you observe carefully, this is the drum. So you have to take the circumference of this drum and calculate the radius by putting 2 pi r equal to circumference, and the radius of the drum should be in meters. So generally already we know that radius of the drum is 0.105 meters, as we have calculated before, and S is the difference between these two weights, S1 and S2. So whatever is more, suppose say S2 is maximum value, so S2 minus S1 you have to take. If S1 is maximum, S1 minus S2 should be taken. So you should not take negative values. So difference of this one should be kept here. So like that you have to write down you have to do the torque values here, and after that slip. The slip formula is Ns minus Nr by Ns. Sometimes you can take N also. So Ns means synchronous speed, where you have taken no load speed. Here the no load speed is 1500. So always Ns will be 1500 and N should be the next reading. So first reading it will be 0, and next reading Ns is 1500 and N is 1475. So like that you have to take, and you have to multiply with 100 for getting percentage. So for percentage slip you have to put here, and after that input power is nothing but W1 plus W2. If you observe carefully, we got negative value in the wattmeter 1 also at the time of starting. After that that came to positive value. So W1 plus W2 value should be taken as input power. Okay, next output power formula is 2 pi nt by 60, because we are taking mechanical output power formula. So 2 pi n is the speed of the RPM, where we have taken 1500 those values, and this is the torque. Just now we have calculated in this formula. So by doing this you are going to get output power. After that efficiency. The efficiency formula is output power by input power into 100. So by doing this you are going to get the efficiency. Okay, generally it won't be more than 85% of the 85% in the 3-phase induction motor. So this is how you have to do, and after that we have to go to we have to take the graph. First we have to take the graph for torque versus speed. So torque should be taken in x-axis and speed should be taken in y-axis. Okay, so the graph will be coming as like this, because 1500 RPM the speed is there. So from 1500 it gradually starts decreasing. So by putting the values you have to draw a straight line with a free hand. After that we have to draw one more characteristics, that is x-axis you have to take output power, and in y-axis you have to take speed, current, torque, efficiency and slip. So like this you have to take, and here if for example if you take the speed value, think that these values are taken here, and draw the graph for this y-axis, okay, and for this x-axis. Like that every graph should be drawn from here only, you should not go from here. Okay, like that you have to draw the graph, and after drawing the graph draw the scale, and also you have to put efficiency symbol, speed, whatever graphs you are drawing you have to put that. So by this we have seen the performance of characteristics, and by observing this we came to know that the performance, the efficiency of the transformer is maximum at 3/4 load, and after that if you give full load it starts decreasing. It starts decreasing. So this is the conclusion where we have found in this experiment. Thank you very much.